So we're going to look at independent and dependent events. I believe this is page 71 of your notebook. I think we're going to go with that. It's page 71 until I tell you otherwise. Okay. And before we actually look at problems, I'm going to give you some definitions. So let's flip it to the back. And let's talk about what an independent event is. What do you think an independent event is?
It's an event that's independent of any other event.
Okay. Yes. Can you, for those that maybe don't know what independent means, can you use a different word other than independent?
Something that does not depend.
Alone. Solamente. Non-reliant.
Ron, okay. All those were good. So I'm going to go with does not rely on anything else.
Remember right there.
I said not dependent.
Okay. Does not rely on anything else. Danya's definition was perfect, but just in case we don't know what the word, I don't know.
It doesn't look right.
It doesn't.
Yeah, well, I'm about to spell relies. That does not look right either.
It was weird for me the other day. I don't know why. Just the word thing.
Okay. What do you think a dependent event is?
Something that depends. Something that relies on something.
Okay, it relies, and I don't know if this is spelled right. It looks really wrong. Okay.
It's right.
I have a math degree, not an English degree. Not that I can do math all the time either. Okay, so let me give you an example. Now listen to both examples before we figure out like what the difference is. So here's my first example. What is the probability, and you're not going to tell me anything else, what is the probability of pulling a king out of a standard deck of cards? Don't tell me what it is. Okay, so that's my first example. Okay, here's my second example. What is the probability of pulling a 2 out of a standard deck and then pulling a 4 if I don't replace the first card? Okay, so let's think. So my first example, what was the probability of, I don't even remember what I said, pulling a king?
4 out of 4.
Okay, would you say that's an independent or dependent event? Independent, okay? It doesn't rely on anything else. Like, I just have a deck of cards, and I'm going to hopefully pull out a king, or whatever we're looking for. My second example is, what's the probability of pulling a 2 and then pulling a 7, and I know that's not what I said the first time. So pulling a 2 and then pulling a 7, but I don't replace that first card that I pull out. That becomes dependent because it changes now my probability. Okay, it depends on the first card.
So independent doesn't change probability and dependent.
Well, dependent depends on something else happening first. So that 7 being pulled depends on what was pulled the first time and whether or not that card was replaced. Okay, I'm not going to ask you which ones are independent versus dependent, but I want you to understand like the difference between the two. Okay. We also have 2 words that are super important. And an or. Okay. So we have been dealing with or probability. So it's pulling a, let me go back. What is the probability of pulling a red marble or a green marble? What did you do in that situation? You added them together, right? You figured out how many red ones you had, you figured out how many green ones you had, and you added them together. So anytime you see the word or, you are going to add. Okay. In my last example, when I was talking about independent versus dependent, I used and, right? What's probably pulling a 2 and a 7? No, we're going to multiply. Okay, well, I'm glad you knew it was something different. Okay, so if you see the word and, you're going to multiply. If you see the word or, you're going to add. Now, and you may see then, like pulling a 2, then a 7. That is going to also constitute as an and. Okay? Yes?
Why do you multiply when you and?
Because it's 2 separate events. Your probability ends up becoming less. So let's think about it for a second. So I have a deck of cards, right? What is the probability of me pulling a king?
4 out of 2.
4 out of 52, which is 1 out of 13, right? Okay, so I'm going to pull a card. Well, it's not a king. Okay, so I pulled this out. Now, what is the probability of me pulling a 7? 4 out of 51. By multiplying those two together, it makes your probability a whole lot less, right? The probability of me now pulling a 7 is going to be less than what it was if I had this card back in the deck. But it's both events because I want the king and I want the 7. So the probability of me pulling both of those cards is going to be super small. If I said or, right, I can have this one or this one, the probability is a whole lot higher because I have more chances. But when I want both, I need both of those for like whatever your situation is to work. Yeah.
I know this is like part of stats, but would we have to worry about like a confounding variable too, or no?
I'm going to go with no.
Okay.
Because I don't know what that is.
What's a confounding?
I don't know what that is. What's a
It's like an independent variable. It's like a second independent variable.
I don't think I've ever heard that term.
Yeah.
But I've also never taken a stats class, so.
I don't think it's stats, but we have to know it for like science and research.
Oh, all right. I'm going to go with that. No. We're good. All right, questions on those? All right, let's go and look at problems. So 2 cards are drawn from a single deck of 52 cards, one right after the other. Okay? Find the probability of selecting a king. I did this example a lot. What is the probability of selecting a king?
1 out of 13.
Okay, so 4 out of 52, which reduces to 1 out of 13. I want you to tell me what that is as a decimal and a percent. That's what your calculators are for. What is that as a decimal and as a percent?
0.076.
How about 0.077 or 0.08? Okay, you should, if you're going to round, you need to make sure you round it. So that 9 rounds a 6 up.
And then
So unless it tells you, I don't care what place value it is. Because the difference between 7.7% and 8% in this situation is fine. Okay, so there is a 8% chance that I will pull a king. That's not very high, considering the highest you can get is 100%, right? So 8% is not very high. And then when I say I need to pull a king and I need to pull a 7, that percentage becomes even less. Okay, so if the first card is a king and the card is not replaced, so I don't put it back in, what is the probability of selecting a king from the second card? 3 out of 51, right? Because I pulled out a king the first time, that's a queen, but I pulled out a king and I didn't put it back in. So I have 51 cards and I only have 3 kings left in the deck because this one's already a king. And that reduces to 1 out of 17. Okay, again, I want a percent, a decimal and a percent. For notes, we're going to do decimals and percents just to make sure we know how to. 5.9.
I got 5.8.
But you should be able to round. So 1 divided by 17 is 588, so you have to round it up to 5.9.
Yeah, didn't you just do 0.06 though?
Yes, you can do 0.06. So it's either 5.9% or 6%. Now that percentage is going down, right?
Yeah.
I have less opportunity to pull a card because I only have 3 in the deck. Yes, I only have 51, but I'm now choosing between a limited supply. Okay? Find the probability of selecting a king from the first card. We know that's 4 out of 52, right? Or 1 out of 13. That's the probability of selecting a king from the first card. And tells us what? And tells us what? To multiply. A queen from the second card without replacing the first card. So what's the probability of pulling a queen? 4 out of 51, right? Because I took a card out and I didn't put it back in, but there's still 4 queens in there. Does 4 out of 51 reduce? No? So I'm just going to multiply 1/13 times 4 out of 51. And that's okay. It doesn't have to have common denominators because we're multiplying. So 4 out of, I think it's 663. Yeah. Okay, I can already tell that that percentage is going to be pretty dang low. What's your decimal? 0.006. My percent is 0.6%. So you have not even a 1% chance of pulling a king and then a queen. Let's see if I can do it. All right? I did, so in 5th period, I pulled out the king, and then I did not pull out the queen. Oh. Okay, ready? I can't even see them. Well,
If she gets it, if she gets a king or queen, we have no fine.
dang it. I got a jack. Okay, well, close enough. Well, so I've already lost. Okay, I want you to try the next one. Oh yeah, I was totally doing the next problem. Okay, well I select, and then I have to replace it. Well, let me put.
That replacement.
With replacement.
So you have to have a jack.
So wouldn't we just do 113 times 113? But she's like,
Okay, what is the probability of selecting a jack?
1 out of 13. Or 4 out of 52.
Okay, 4 out of 52, which reduces to 113. Everyone agree with that?
Yeah.
And tells us to multiply a queen from the second card with replacement. So I put that card back in.
So you multiply that.
So 4 out of 52, which is 1/13. That's a 1 over
169.
169. And you should have gotten 0.006, which is 0.6%. Okay, you always have to round. You can't just use, like if we're taking only part of the decimal, you have to make sure you round. So whatever part you take, you have to round. Okay, now the last one takes a little bit of thought, and I want you to think and do it. All right. Find the probability of selecting a 6 or a 7. How many 6s are there? 4. How many 7s are there? 4. So 8 total, because for or we add, out of a total of 52, which we can reduce to 2 over 13. Okay? In the first draw, and tells us to multiply an 8 or a 9. How many 8s are there? 4. How many 9s are there? 4. Or tells us to add without replacement though. So that was out of how many? 51. Good. Every other class got 44 because they subtracted 8. Yeah, I don't know why they did that. Because remember, you are taking one card out. It's a 10. Right? And not replacing it. Okay, does 8 over 51 reduce? Nope. So you get 16 over 663, which is 0.024 or 2.4%.
Do you have to write the 0 before the point?
No.
Oh, okay.
Does it make sense that the probability is a little higher than like the one above? Because I have more options to choose from,
Yes.
right? I have 6 or 7 first instead of just a jack. And then I have 8 or 9 instead of just a queen. Okay, so the probability is going to change. Now, what is my probability? What is the probability of me choosing a red card? 50%, right? 1/2, because it's 26 out of 52.
Yeah.
So the more that I put in like my sample set of what I can choose from, the higher that probability is going to be. Any questions? Okay.